Hi everyone, I hope I'm audible. I'm waiting till 6:10 so that a few more people shall join by that time, and then we shall start. Hello, am I audible? Let's wait till 6:10. 7 more minutes, so that for more, let's wait for some more people to join, and then we shall start. Um, let's wait till 6:10, and we shall start. Let's wait for some more people to join. let's wait till 6:10 and then we shall start. Let's look for some more people to join. Today we will be revisiting, or today we will be going through the concepts. Actually, first assignments of week 7, 8, 9, and then we will be going back to link analysis and chapter number 4, I think. So in last class, I taught. What did I teach? Network growth models. And today, just a second. Yeah. So today I will teach you guys first of all this thing, assignments, and then we will visit link prediction and everything. And I will share my notes as well. I have some notes with me which I've been teaching. Let me export them and upload them. So in this sheet, I'm sharing my screen. The screen should be visible. In this sheet, you will find this one, this link here, this Google Drive link. Okay, I will be uploading this notebook. Revision. Okay, so please go through that and watch the previous week's videos to get more understanding about what we have studied till now. Hi Manjesh, how are you? Generally by week 10 or 11, the attendance falls short, and I'm not surprised actually. There are like few people. So what I was telling Manjesh is, if you open this sheet, whose link you can access from here in the announcements, okay? And if you open this sheet, what you will find is, you will find this Google Drive link. In this Google Drive link, you will be getting this revision PDF. Let me open it to show you. It contains everything which we have revised till now, and the videos about these you can find here in the sheet as well. You can go through this revision from week 5 and get to revise. Okay, so let's start actually. Let's not wait for any more time, because people, I don't think so, won't be joining. So week 6 till week 6 we have done. Week 7 actually week 7 we also done. Let's go to week 8, 8, 9, 10. 10 if the deadline is over, otherwise 8 and 9 we will discuss. Okay, so is my screen visible? Yes. So week 8 was all about cascading, information cascading and all. So K-core, a K-core is a graph which has which in which every vertex has at least k edges. Okay, that is a K-core. Just a second. That is K-core. Suppose you want to model COVID-19 using a epidemic cascade model, given that individual remains susceptible to infection after recovery. Okay, so let's study. I'm connecting my iPad. Wait a second. Let me share the screen of my iPad as well. So I just write in this notebook only, so you don't have to worry about seeing like another file. So assume you have an individual eye that is infected, or it's an individual K. This individual is infected. Then, sorry, this is susceptible. Then it becomes infected. Then it recovers. After recovery, it becomes susceptible to infection again. Okay, so the output will be SIS. Hope so you are able to see my screen, both the screens, iPad and PC. Okay. Okay, so this is SIS model for COVID. SIR is the question number 3. SIR is susceptible, infected, recovered. Okay. Information cascade, what term is used for final set of nodes that are affected or influenced? Those are known as adopters. Okay. The final propagation tree obtained by the spread is known as contagion. I don't know. Contagion is the flow of information. The tree is known as something else. Let me check. Propagation tree. Yeah, propagation tree. So not the propagation tree. It's called as transmission tree. Yeah, it is transmission tree. I hope I'm not boring you. In decision-based cascade models, the node's precision tries to optimize the reward for its local community too. Okay, all are true, false. I don't like the rate of infected population depends on the birth rate. No, in SIS model. I is proportional to birth rate by death rate, something like that. SIS model, recovered node cannot be infected again, false, because COVID-19 in this question we already seen that it can be infected again, so that is SIS model for you. Given the following graph, G1, the first node is a hardwired adopter of A while the other nodes have adopted B. Okay, the first node is hardwired adopter of A while the others have adopted B. The payoffs for adopting node A and B are A and B respectively. The cost of adopting A, B irrespective of neighborhood is C. Okay. Between two interacting nodes, consider the following scenarios in payoff table 1. Okay. When A is 5, B is 2, C is 1. So for node 2, what is the lowest one? See, for node 2 is at B. Okay, it has to go to A. Okay, you can take this one as well. And to go to AB, B to AB should be B, but B to AB is C actually here, it's given. Which is the lowest one, like payoff. So the answer is AB. For node 3, the answer is AB again. No, just a second. Node 1, determine node 2 and 3. Okay, max of AB. Let me change this. Just a second, I'm solving this question and I'll tell you the solution. Okay, so the payoff for node is the sum of edges payoffs to its neighbors minus C if it chooses AB. So node 2 has neighbors 1 and 3. So choose A, you get 5, choose B, you get 2, choose AB, you get 5 plus 2 minus 1, 6. It's the highest, you choose AB. For 3 as well, 5, 4, and again you choose AB. Then you get max of this thing, that is 5 plus 2 minus 1 is 6, so you choose AB again. So this is week 7 done. Sorry, week 8 done. Let's go to week 9. Hi Shrikant. So I just started giving solutions to week 9 assignment. So you just joined at the right time. So week 9 also had 10 questions. As per our oh sorry, this is not a question. EgoNet is defined as a subnetwork induced by one hop neighbors and itself. It's not a two hop neighbors ego network. My screen is also visible here. I'm making it here. So this is an ego network. Well, this is known as ego, and these all are known as alters. So that is one hop ego network. So this one is the answer. Common neighbors and Adair indices techniques are used in which category of network? So that is basically proximity detection, proximity-based search, proximity-based approaches. Okay, because community approaches use Louvain and the other techniques, structure-based approaches do not utilize common neighbors as per se. They utilize the whole structure. Window-based utilize the sliding window. So this is the other answer remaining here. In window-based method, what is the term used for the number of elements kept between the starting points of two consecutive windows? It's hop length. Let me just draw it. So Assume this is a network, okay, and you are here. Okay, so if you like start window method, so assume your current window size covers only 3 nodes. Okay, so you take these 3 nodes in this structure and like study whatever you want. Then you take a hop length of 1. So the next 3 nodes will be like this. If I choose hop length 2, then I will be skipping this node, and I will be going to these 3 nodes. So this is what hop length is. Okay. Which of the following is not a network-based global feature? Average node degree is network-based. Number of connected components is network-based. MSP weight is network-based. Only closeness. Closeness is defined by the neighborhood. Not a global feature. It's not a global feature. It's a local feature. Which of the following is not a node level feature? Modularity is used for community detection, so it's not a node level feature. It's a mesoscopic feature. Betweenness is microscopic. Eigenvectors microscopic. Degree assortativity is microscopic, and the modularity is mesoscopic. Which of the following is not a generic feature based approach? Graph edit distance utilizes just let me so these net vectoring network, lambda distance, these all just study the graphs. Okay, while this one studies the matrices, so it's not a feature based approach, generic feature based approach. Outlier detection is not different from network anomaly detection. False. Outlier detection and anomaly detection are different. Anomaly is in a network is something which can cause aberrations in network. It causes a network to misbehave, while outlier is something which can exist in a network. Its existence does not make the network, fragile, while this one can cause some issues. Outliers exist anywhere, anomaly should not exist in a network. In a dynamic network, both nodes and edges can change over time. True. Consider as a class, we are analyzing the communication patterns among students and instructors using oddball algorithm to detect anomalies. In classroom A, all student communicates for far more with the instructor than each other. What kind of anomaly? It is a near star anomaly. Okay, because you are going to the edges. Let me just draw it. So assume these are 3 friends, A, B, C, and this is their teacher, and they communicate with teacher only. They don't communicate with each other. So this is a star. Okay. Had they been communicating with each other as well, this will be a click. So see, frequently with each other as well as instructor. So it is a click because all nodes are connected with each other. So it's not like if I assume this one as well. So like this node is not connected to this node is connected to this node. It should be like that. They should be all connected to each other. Okay. So this is a near click feature. Okay. So this is all about week 9 assignment as well. Let's see week 10. I think the deadline is still not over yet. Yeah, it's in 5 days. So we will study this next week. Next week means the next session. Let's start studying this thing, information cascading. So today's revision class, we will be studying information cascading. So to study information cascading, first of all we need to know what is information. Information is something which makes you knowledgeable about something. You get to know some information and you get to know about that thing in that perspective. So the problem with getting information is that being humans, we like spreading rumors. Not rumors per se, we like to engage in gossips. And I think this is one of the reasons of our evolution as well. Gossips have led to our evolution to this stage of to the stage of a strong social system. Had gossips not existed, we would have been living as individuals, not as a society. So this is why information is important for us as a human. Otherwise, we will just be like busy with our work like robots do. Because consider robots know everything, so they do not need to exchange any information. So they will be like waking up, getting the work done, and going to sleep. That's all they're gonna do. So the social system, the social network, the social status quo will collapse. That's why information needs to spread, and that is why the study of spreading of information is known as information cascade. So information cascade is not just related to information, it is also the basis of foundation for epidemic models. So I will open a web page here and I will explain how that works, epidemic models. Okay. Where is it? Epidemic models. Where is it? Let's go to API mode and let's see what it is going to give us. Yeah. So the most common, or like not the most favorite model, I would say, well, let me just explain what is a epidemic model first. So epidemic models study the flow of disease, or basically should I say life cycle of disease spread. Nobody wants to get ill, everybody wants to be healthy, but we do get ill, and that is what makes us human. Otherwise we would be just cars, mobiles running on batteries. So manuals also, they fall in. But anyways, so the most favorite model anybody wants to be following is SIR model. SIR is susceptible, infected, recovered. You are susceptible to infection, you are like getting in contact with some virus, bacteria, you become infected with that, you fall ill, you take medicines and you recover. Okay. But the problem is not every disease follows the not every flow of disease follows this thing. Okay. So which one follow that? So assume chicken pox. It is a general convention that once you get chicken pox in your life, you don't get it again. So you are susceptible, you come in contact with someone who has chicken pox, you become infected with chicken pox, you recover, and then you never get this disease again. But most of the diseases in real world do not follow this thing. Okay, you have to become ill is their own agenda. So then comes SIS model. So SIS is susceptible, infected, okay, then become susceptible. Okay, so for example, common cold. Against common cold, you do not develop any immunity. You get it, you recover, you can get it again in a week. So that's why there is no recover here. So if I add like SIRS, you recover and then you become ill. So for example, diseases such as what should I say? Which develop an immunity against something. So assume like this common cold, this is like viral fever. So in viral fever you recover, you gain some immunity, but after some time that immunity drops to zero and then you become susceptible again. Okay. So this is SIS, SIR, SIS, SIRS, in three models. The next model of disease modeling is SEIR, where this becomes exposed. What is the problem in getting exposed? Exposed is you are exposed to the virus, you are not ill, okay, but sorry, you are exposed, you are ill. Let me just note this. You are exposed, you are ill, but you are not contagious. So an infected person becomes contagious and it becomes a medium for infection for susceptible people. But exposed does not cause any spread of infection to susceptible people, so it just stays till here only to itself. Then becomes infected, it starts spreading, then it becomes recovered. So for example, let me tell you an example of that. So what should I say? I think there are no such diseases. Like there are some diseases such as TB. Okay. Tuberculosis has this issue where this becomes a problem, where like in exposed state it does not infect anybody else, but once it becomes infected, then by coughing tuberculosis can spread to others as well. Okay. These are some of the epidemic models. The others one are like rumor spreading and all. They are not used for diseases, they are used for rumor modeling. And then there is CBPNR. Sorry, I did something. Hi Vimal, we are just revising this thing. The other one is SADPNR, which is basically modeling the bias, confirmation bias of humans, the emotions as well. So this is susceptible emotion when there's the doubt. That stuff, it's out of scope of this course. You can study it later on. So this is all about information cascading, epidemic modeling. So let's also study information cascading. Let's study types of cascades. Yeah, this is very important to study. So now we have studied this stuff. Let's study one small topic on information cascading. So information cascading is of two types. One is decision based, the other is probabilistic. So let me give you an example. Assume I am going to a restaurant. I love the food of that place, and I recommend it to other people. So this is really fine. Sorry about that. So I recommend to other people by word of mouth. The restaurant is not basically advertising themselves. So I'm also not an agent of restaurant. So I go and I say to people, yeah, I love restaurant XYZ. They serve really nice food, and the only thing bad about them is like their lighting and all. So like they get to know, yeah, this restaurant is really nice. Their downsides are not as important. So they make decisions on those factors which I tell them. Okay. So they make decisions based on the factors which is conveyed to them. So this is basically decision based cascade. Okay. So I will tell, they will go, they will visit, they will tell the same thing, or they will remove some things from my description and they will add something on their own. That's completely fine. So that's basically like creating a cascade tree which some other person will pick, and they will follow something from that, and other leave the just remaining things. That information cascade about decision making using decision based cascades. Now assume in this, like, I'm not an agent of restaurant. I am not worried about if people visit it or not. But in probabilistic case, I am like, assume I am advertising. I am the owner of restaurant and I am throwing away flyers. And I want people to come. So there is a common conformational bias in humans which makes us not trust somebody. Is Chinnam, please mute yourself. I'm muting you. Sorry about that, I have to mute because I'm speaking. Okay. Yeah, where was I? Yeah. So we humans do not trust advertisements. We make decisions by studying them, studying a product, searching about it, and then buying it because it's our money where it's going. Okay, so we again rely on decisional cascade of someone else to make decisions. So basically, this restaurant owner, okay, sorry, this will expect customers with some probability. So it will assume say it will say assume 30% people will come just by seeing the flyer, and 20% more people will come by asking others about the restaurant. Okay, so now it becomes a game of percentages. It becomes a game of probability for this user, for this restaurant owner. So that is why it is known as probabilistic cascade. Ultimately, the decisions are made by asking someone else, not relying on advertisement. So when someone is not relying on something exactly, that becomes a probabilistic model. Okay. Also, diseases are also probabilistic. So basically, this epidemic modeling is probabilistic. So yeah, this is all about information cascades. Now we are done with the revision of one of the most important topics. Let me just re-upload this file. This file needs to be re-uploaded again. Let me export it. Export all. Leave. So I'm uploading it again. This becomes revision. I'm deleting this because it's the same file. Okay, so what you can do is you can refer to this one. Last pages to get to know what I taught today. I taught a lot of things today. And in next class we will see week 10 assignment. We will solve week 10 assignment in detail because the deadline is still not over. So October 1st is I think Thursday, October 2nd is Friday, I don't know, like, no, October 3rd is Friday. So yeah, we'll discuss this on October 3rd after the deadline is over, and by that time, by next week I have also released the solutions to all the assignments, detailed solutions to all the assignments of previous year. And that way you can study all the questions for the exam, because these questions will be coming in exams as well. So like more or less these questions will be coming. And yeah, that will be all from today. If you have any doubts, just let me know. I'm waiting for one more minute. If you don't have any doubts, we can leave this and let's meet next week. Let's wait for one more minute and then we should cool then. I think if you don't have any doubts, let's stop and let's meet next week. Till then, bye bye, see you, take care, have a nice weekend, enjoy.